going to do is try to bring all that together and just put it into the context of an industrial process. So here we've got the Haber process for making ammonia used in the production of lots of things, including fertilisers. Let's have a think about each thing. So if we're going to talk about pressure, what's job number one? Can you remember what the first thing you need to do when talking about pressure is? So let's remind ourselves. So the first thing to do when talking about pressure is to decide which side has the higher pressure, which side has the lower pressure, and then you can have a think about the effect on the position of equilibrium. So pause the video and fill in these two boxes, the effect of increasing or decreasing the pressure on the position of equilibrium. And you should have got that. And could you explain it in an exam? So could you say that it shifts right to oppose the change and reduce the pressure? So what effect would that have on the yield of ammonia? So if we shift right, then we're going to increase the yield of ammonia. If we shift left, we're going to decrease. So which of these is our chemist aiming for? So if I was the industrial chemist and I was trying to decide on the conditions for my process, this would be what I would be looking for. So I'd be going for an increase in pressure. What about rate? So go back to your study of rates of reaction, that's a different area of chemistry, and tell me what effect increasing pressure or decreasing pressure would have on rate. And there we go, we know that increasing the pressure increases the rate. Could you explain that in terms of collision theory? So could you say there are more particles per unit volume, so more collisions per unit time? So looking at our first condition that we can change as an industrial chemist, it seems sensible to increase the pressure in this process because it's going to give us a better yield and a better rate. Right, let's take a look at the next. What's the first thing we need to do to our reaction thing to decide what happens with temperature? The first thing we need to look at is what that is, and that is XO. So that means it's getting hotter as we go from left to right, which means it's getting colder when we go right to left. So can you fill in these 4 boxes here that are to do with equilibrium and the fact that it's exothermic? So we should have got shifts left when we increase the temperature in the endothermic direction to absorb the heat. And in order to get it to make more ammonia, we're going to have to decrease the temperature. So in order to get our smiley face, we have to decrease the temperature. What about rate though? How does increasing and decreasing the temperature affect rate? So increasing the temperature increases rate, and make sure you can explain that in terms of activation energy. There are more particles with energy greater than the activation energy, so more collisions are successful. But notice now our smiley faces are on different changes. So for rate we need to increase the temperature, but for equilibrium and yield we need to decrease the temperature. So we're going to have to make some sort of compromise. What other things happen in the industrial process for making ammonia? Well, we add an iron catalyst. See if you can fill in the row for iron catalyst. So a catalyst has no effect on position and therefore yield, but does increase the rate at which we achieve that yield. So it is useful to add a catalyst, particularly when we've had to compromise on temperature in order to get yield. We've reduced the rate, so we might need to boost that rate back up. And one of the other things that they do in the production of ammonia is they remove the ammonia as it's formed. So what effect does that have? If I take out my ammonia as it's formed, what effect does removing the ammonia have on the position of equilibrium? See if you can fill in that line. So there you go. If you remove the ammonia, we're going to shift right and make more, so that's increasing our yield. Removing ammonia does not affect rate of production in any way, because we're not affecting the rate of the forward reaction. So what conditions do they use in the Haber process and why? Now you don't need to know these specific numbers, just to be able to explain why we use them and why they might be considered compromises. So just have a little think about why we choose these amounts. Why not 5,000 atmospheres? Why do we stop at 200? Why 400 degrees C? Why do we add a catalyst? And why might we recycle things in the process? So just have a pause the video and have a think about why we would do those. So our pressure is high enough to increase the rate and yield, but it's not so high that the equipment needed is expensive and the safety concerns need to be too worrying. You mustn't just write it's expensive. What about high pressure is expensive? It's actually the equipment that's expensive. The temperature is high enough for rate but low enough for yield, so it's a compromise between rate and yield. We add the catalyst to increase that rate, and we recycle any unreactive nitrogen and hydrogen to reduce raw material costs.